Welcome dear students. Welcome to Chemistry Fundamentals. I am Dr. Rajiv Oberoi. Let's deal with a very important topic in solution, especially in the topic osmosis, and that is the isotonic point. What is isotonic point? As we have already discussed in the previous video, that what is meant by isotonic point. So we say isotonic point is the point at which the concentration of two solution across the semi-permeable membrane becomes same. So at isotonic point, very important, at isotonic point, the osmotic pressure of solution A becomes equal to osmotic pressure of solution B. Why? Because concentration of solution A becomes equal to concentration of solution B. Which concentration? So there are various representation of concentration. It is mass percentage, molarity, molality, normality. But we use molarity because molarity is temperature dependent. So at isotonic point, molarity of solution A called as Ma becomes equal to molarity of solution B, Mb. So A is molarity of A, Ma is molarity of A, and B is this Mb is molarity of B. Now how molarity is expressed? So we say molarity is expressed by writing moles by volume. Whenever we write mole by volume, it means molarity. Moles by volume is termed as the molarity. So since N is equal to M is equal to N by V, M is equal to N by V, therefore at isotonic point N1 Na upon Va is equal to Nb upon Vb. Molarity of one becomes equal to molarity of the other. Molarity of one becomes equal to molarity of the other. Molarity is expressed by N by V. Therefore, mole of A becomes Na upon Va is equal to Nb upon Vb. Now, since N is equal to W by M, N is equal to W by M, therefore, we can say that at isotonic point, W1 upon M1 into 1 upon V1, we are substituting the value of N. W1 upon M1 into 1 upon V1 is equal to W2 upon M2 into 1 upon V2. This formula is applicable for the numericals but applies only at isotonic point. This is applicable at isotonic point. So let us deal with the numericals based on the isotonic point, that is the isotonic solutions. So let us deal with the numerical based on isotonic solutions, those solutions which are isotonic to one another. So if two solutions are isotonic, then this formula M1 W1 upon M1 into 1 upon V1 is equal to W2 upon M2 into 1 upon V2 will be applicable. So if a problem is given to us, problem says 10% urea solution by volume. 10% urea solution by volume is isotonic to 15% solution of some unknown solute. Find out the molecular weight of unknown solute. So we have been given two solutions. One is urea, which is 10% by volume. Other is unknown, which is 15% by volume. We have to calculate the molecular weight of unknown solute. The molecular weight. Now, if we discuss the solution for this problem, we have been given since urea solution is 10% by volume. Urea solution is 10% by volume. It means that 100 ml solution contains 10 grams urea by volume. Therefore, 100 ml solution contains 10 grams urea. So, weight of urea is 10 grams. The molecular weight of urea, as we know, is 60 because its formula is NH2 C double bond O NH2, and volume of the solution is 100 ml. So weight of urea is 10 grams, Molecular weight of urea is 60 and volume of solution is 100 ml. This is for the first solution, that is urea solution. This is for the urea solution. Now for the unknown solution, if we discuss, for the unknown solution, since this unknown solution is 15% by volume, unknown solution is 15% by volume, therefore 100 ml of solution contains 15 grams of that unknown solute. 100 ml of solution contains 15 grams of that unknown solute. Now weight of unknown solute is 15 grams. Molecular weight of unknown solute, this is what we have to calculate, the molecular weight of unknown solute, and once again the volume of the solution is 100 ml. So we have the volume of urea, the percentage of urea, and since substance given, therefore we know the molecular weight. In case of unknown solution, we know the percentage, it is 15. We know the volume of the solution, it is 100, but we have to calculate the molecular weight of the unknown solute. Molecular weight of unknown solute to be calculated. So let's substitute the value. Now on substituting the value into this equation, so this equation is W1 upon M1 into 1 upon V1 is equal to W2 upon M2 into 1 upon V2, which is applicable only at isotonic point. So only two solutions when they are isotonic, then only we can apply this. So on substituting the value, it would be the weight of urea is 10 W1 upon its molecular weight 60 into 1 by volume is 100. Weight of unknown is 15. Its molecular weight unknown. Volume again for the unknown is 100. So when we can, this 100 get cancelled out. So what is value of M2? The value of M2 is 15 into 60 upon 10, that is 15 into 60. This M2 comes to be 90 AMU or grams per mole. So what is M2? It is molecular weight of unknown solute. Molecular weight of unknown solute, which is coming to be 90 AMU. Very, very important. Whenever you express the answers, the unit is very, very important. Please ensure that you always write a correct unit. If you are missing the unit, you are missing the marks. So M2, which is molecular weight of unknown solute, is 90 AMU or grams per mole. Let us discuss one more numerical based on isotonic point. Question goes, calculate the amount of sucrose that should be present in 200 ml of solution for it to be isotonic with 12% urea solution by volume. Calculate the amount of sucrose that should be present in 200 ml of solution for it to be isotonic with 12% urea solution, which is by volume. Now if we solve this problem, so weight of urea given is 12 grams. Weight of urea is 12 grams. The molecular weight of urea, as we know, it is 60 AMU. The weight of sucrose, this need to be calculated, and the molecular weight of sucrose, as we know, it is C12H22O11, it is 342 AMU. The weight of urea is known, molecular weight of urea is known, weight of sucrose to be calculated, molecular weight of sucrose is known. So by substituting these value into this equation, we can find out the weight of sucrose that should be present. Since two solutions are isotonic, therefore the equation related to isotonic point can be applied. So if we substitute the value in the equation, the equation is W1 upon M1 into 1 upon V1 is equal to W2 upon M2 into 1 upon V2. This applies to, one applies to urea, other applies to sucrose. So if I keep value for urea and sucrose, so for urea the weight taken is 12, its molecular weight is 60 into the volume is 100. It is 12%, 12 per 100, volume of solution is 100. For sucrose, the weight of sucrose present to be calculated, its molecular weight 342 is known, and volume of the solution as given in the question is 200. Now if we substitute this value and solve it, the value of W2, the weight of sucrose that should be present in 200 ml of solution comes to be 136.8 grams. It comes to be 136.8 grams. So weight of solute, that is the sucrose, the weight of sucrose that should be present in 200 ml of solution for it to be isotonic with 12% urea solution is 136.8 grams. So this is how the numerical based on the isotonic point are calculated. What is isotonic point? So isotonic point is the point where concentration of two solution across the semi-permeable membrane becomes same. So I hope that this topic of isotonic point, isotonic solution and the numerical based on them is clear to you all.